Okay, this is from the last time we had finished up with the ventricles, or the anterior view of the ventricles. And what I did is I just drew in the ventricles here, and I said we were going to connect the meninges and then put everything together. So what you need to know is that the first layer of meninge that is very tightly adhered to the CNS, what was that one again? We drew it in green. That's your pia mater, good. That's your soft mother, okay? So this is very tightly adhered. So here's your midbrain, your pons, your medulla, all the way around your spinal cord, all the way together. Take this. This is all very tightly adhered to your PNS. Or to your CNS, not PNS. Okay, quick review. What's the layer above that called?
Arachnoid.
Yeah, that's your arachnoid matter. And you remember your arachnoid matter, I think last time I did it in this maroon color, there's a space between the pia mater and the arachnoid matter, if you remember. So kind of like that. And that space is maintained by little projections called, anybody remember what the little projections are called? Trabeculae. So these are the trabeculae here. And it helps maintain that space. Okay. And in that subarachnoid space, what's in the subarachnoid space? Does anybody remember? What's it filled with? CSF, great. CSF, and also there are free-floating cerebral veins and arteries in that space as well. Okay, and these colors should be consistent with what we did before. So we have your arachnoid matter. Trabeculae. We have pia mater here in green, and on the next we have something that is the next layer. It's the layer of dura that is not tightly associated with the bone. It's the underlaying layer of dura. Does anybody remember what dura that is? That's your meningeal dura. Great. Your meningeal dura, you should know that your meningeal dura goes all around the CNS. Okay, so it's all around the outside of the subarachnoid, of the arachnoid matter. Goes around the spinal cord, midbrain, pons, medulla, all the way around the skull here. And that's your meningeal dura layer. Okay, sort of a quick review, and then that last layer that's very tightly adhered to bone, especially in the skull, is called that's your periosteal dura. Okay, now there's something important that you have to remember about the periosteal dura. It is only around the brain. It is not around the spinal cord. Okay? So it is only attached to the skull on the inside. It doesn't go any lower than that. So to represent that, I'm just going to put the periosteal dura here around the skull. part for the brain. And that's your outermost layer is your periosteal dura. Okay, I think we've covered everything. The only new thing that I added on there at the end is that the periosteal dura is only lining the inside of the skull. When you get down to the level of the spinal cord, it doesn't go any lower. It's only the meningeal dura that goes over the spinal cord proper. Questions about that? And that's pretty much, yes.
What
Anna.
color did you draw that?
I'm sorry, what color what?
Did you draw that in?
That's darker blue.
Or which one is it?
The dark, this here, this dark blue color right here on the outside. Yeah, so the meningeal dura is, it's labeled up here. The meningeal dura is that kind of aqua color, and the darker blue, that's your periosteal dura. Okay, and I just have it around the inside of the skull area. Okay, any other questions? Okay, now, there's something that you need to know that makes CSF. Does anybody know what makes CSF? It's a specialized structure called a choroid plexus. And I'm going to represent the choroid plexus, and the choroid plexus are found in all of your ventricles. So I'll put one here in one lateral ventricle, and then another one here in this lateral ventricle, and then in your third ventricle. There are multiple in all of your ventricles. So they're in here the third, and I'll put one down here in the fourth ventricle. So all of your ventricles are responsible for making CSF. And what they use to make CSF is this structure. It's actually a specialized kind of ependymal cell. We'll talk about that today. It's called your choroid, C-H-O-R-O-I-D, plexus, P-L-E-X-U-S. So your choroid plexus makes CSF. Okay, so it's nothing more than a specialized kind of ependymal cell, kind of glial cell, that makes your cerebral spinal fluid. Okay, CSF has a couple of functions. As I said before, it fills this subarachnoid space overall. And you can see what happens is as the CSF is made in these choroid plexus, it's going to be the foramen magendi and the foramen oblongata here that are actually connected, as you can see, to the subarachnoid space. So the CSF is made here, but then it filters out through into the subarachnoid space all the way around. And it does that by flowing through the foramen magendi and the foramen oblongata in the fourth ventricle. That's the importance of that. Okay, does everybody see that? Now CSF is going to provide buoyancy. Okay, so just an extra layer of, whoa. Okay, I don't have a,
Dude, I'm telling you, bad luck day.
I don't have a,
There's some in the room.
okay. Yeah, it's going to provide buoyancy, and like I said, inside the CSF is where the cerebral arteries and veins are floating, and that's going to provide extra protection. So, it's also, CSF is also going to be involved in metabolite removal. Okay, so any metabolites that have to be removed are going to be picked up by the CSF. And yes?
Sorry, what is the word right before protecting say?
Protection? Buoyancy.
Oh, okay.
Spell that wrong. Yeah, buoyancy. And it's going to also provide a stable ionic environment. So CSF itself is kind of like water. There's not a lot to it. It's acellular, doesn't have a whole lot of protein. It's just a good neutralizing solution for the CSF, for the CNS overall. Question?
But you said stable ionic what?
Environment.
Environment.
Yeah, stable ionic environment. So it's just going to be a nice neutral fluid to keep the CNS comfortable. That's what it's saying. Yes.
Can you circle back to the foramen of Luschka, the details you're talking about with pregnant arachnoid?
So essentially, the foramen of Luschka are the two on the outside, and the foramen of Magendie is the one in the middle that goes out the back, and it's open to the subarachnoid space, so it allows the flow of cerebral spinal fluid into the subarachnoid space. Yes, Brady?
Outside of where the foramen are?
I'm sorry, can you say that again?
Is there like a matter outside of where the foramen
Yeah, so the pia, there's a hole, the foramen are the hole, so the pia mater doesn't cover the hole. It's up to the hole and then picks up outside the hole. So imagine it as like a channel. The pia mater doesn't cover the channel. Okay? Any other questions? Does that make sense? So you make your CSF in your choroid plexus, and then it filters in and is throughout the subarachnoid space. But now they were talking about this, you just saw the video on hydrocephalus, right? And hydrocephalus is nothing more than the buildup of CSF in the ventricles specifically. So that means there has to be a way for the body to get rid of extra CSF from the subarachnoid space. And what happens is that there's something called an arachnoid villus. And it is going to, I'm trying to come up with a color that would be different here. Your arachnoid villus is nothing more than a structure that connects your subarachnoid space. If you remember that superior sagittal sinus here, let's label that. This is your arachnoid villus. And actually, they're arachnoid villi. There's a whole bunch of them. You can think of them kind of like the bridging veins, only they're specific for taking up CSF from the subarachnoid space and dumping it into that superior sagittal sinus. Okay, so arachnoid villus. So these are just structures that allow the flow of CSF from the subarachnoid space into the superior sagittal sinus. And I'll just abbreviate that, SSS. So they're just specialized structures that allow the CSF to flow from the subarachnoid space. Otherwise, there'd be a serious buildup of pressure in that space. And that's how things get drained. Question?
What did SSS stand for?
Superior sagittal sinus. Yeah, that little, there's a little structure right up in here that I didn't draw. That, remember that superior sagittal sinus? That's going to be your main venal drainage system, yes.
So instead of that gets backed up, stuff like hydrocephalus.
Yep. And so if the flow of CSF isn't happening from the subarachnoid space into the superior sagittal sinus, what happens is these ventricles swell, right? And you can imagine there's all kinds of brain structures here, and as your ventricles swell, you get problems. You start to get the symptoms. Other questions? So that's what essentially is hydrocephalus. That's what causes it, and you can now see the connection between the ventricular system and the meningeal system. It all works together. Okay. Questions? All right, let's go ahead and move on to the next part then.